That makes me look terrible, doesn't it? So you were saying, I was saying no.
I'm so good at integration.
I'm going to go, you have a bit of pain, I hope I'm right, your eating is good. So we've got a point here, where it's elastic, and we're moving down, and we've gone from minus 3.5 to minus 2/7. And somewhere in here, it's going to be unit elastic. Because you can see here, it's minus 2/7, which, if any of you are good at decimals, might be able to tell me what that is. But I'm not very good. And so this is lower than minus 1, and we're moving along. And so we must pass through 1 here. Does that make sense? Because we're at minus 3.5 here, and we're at less than 1 here. So some point in between is going to equal 1. Minus to right. A lot of textbooks you'll find actually, when they look at right elasticity, just deal with the modulus of it. So they just say, oh, we're just going to take it as positive. I'm going to stick with actually this one, Q equals 27 minus 3p. 7. And we're going to try and find this point, P and Q. Might do a new diagram so we'll get a bit messy. P and Q, where n equals minus 1. So we're going to set n equal to minus 1. So we get minus 1 equals minus 3p divided by q. Just taking the p up here, it's the same thing. So now I can scrub off the minus signs already. That's going to help us to deal with this mathematically. So if I times both sides by q here, again we're going to get q equals 3p. I'm really not very good at writing now. Should you get a scribe?
No,
and we're going to say that this here is this here isn't going to actually help us. We can't find P and Q with this, and we can't find P and Q with this. But if we combine them together, we can find P and Q because both of these still hold. So because Q equals 3p and Q equals this, we can say that 3p equals 27 minus 3p. Bit of algebra. Add the 3p over here, we get 6p equals 27. P equals 27 over 6, and Q equals 3p, which is that times, or you can say it's 3 times this, which the 3 is going to go here if we divide it by 2. So Q equals 27 minus over 2. Sorry if that didn't make much sense, we didn't do that very well. So we've got P here as 27 over 6, so Q is going to be Q equals 3 times 27 over 6, and now what we can do is we can, because 3 over 6 is a half, we can just get rid of that and we can change that to a 2. So, I don't know, I got, get rid of that sign. So we've got Q equals that. And that's this point. And like I said on the PowerPoint, and I was thinking about this in the shower actually, yesterday. I was thinking, I'm going to explain to them the point. So I'm going to explain to them the point where you can find unit elastic tomorrow. And they're going to be like, oh, that's great, but what is the point of doing it? So there's a bit of a play on words there. We found the point, but what is the point? You're not expecting to laugh. But there is a really, really important point. And I was trying to think what it was, and I remembered it. If I draw, I'm going to draw a new diagram. Someone's getting too confusing now. Sorry, I can't do straight lines. That's terrible.
LSE, really?
I can't draw a straight line. You don't have to do it. Yeah, I can't do massive metal roof used to smash them.
I feel like that one never had kind of the teacher.
It's still really not good at all, but I was going to have to do it. Constant.
We've only ever had spell, that's quite scary, isn't it?
That's why we did so well in our tuition. Yeah.
Yeah, we are doing better than your class.
Why is it directed by level?
We've got loopholes.
The fact we keep some
This other one.
All I've done here is, it's fine, you can talk, I was just drawing out another thing. I've just drawn this exactly the same for this same one. We've got a point here, which we found, which is a point where it's unit. And we know that all the ones here now are elastic. We've shown that. We found the point here, and we've shown that it's elastic. And all the points here are inelastic. And we found this point. Now let's pretend we're a firm. And firms, most of the time, want to maximise revenue. So they think, how can I maximise revenue? But if you can remember back to your economic knowledge, if you're at this point, if demand for all these points is elastic, if you raise price and demand is elastic, then your revenue is going to fall. Do you remember that from learning economics? If demand is elastic and you raise price, revenue is going to fall. Now let's go down. If demand is inelastic and price falls, you lose revenue. So now what we know is that at this point we've found revenue is maximised. I'll bang it on there just to make it clear. At this point, revenue is maximised. So if a firm wants to know at what price to set for its good, if it knows the demand of the market and it wants to maximise its revenue, it finds this. Yes, Matt?
Is that the case on any demand curve? Any demand curve?
Any downward sloping demand curve, yeah. For any shape, any downward sloping demand curve, yeah. Biff?
But didn't we learn that when you raise price when it's inelastic, you also increase revenue?
Yeah, well, what I've said...
Regardless of the shape of the curve, once you find the midpoint.
So you cannot increase revenue anymore?
You can't, because at this point, even if you change the price, if you raise the price, you're going to lose out. If you lower the price, you're going to lose out. So that tells you, by recognition, that you're at the point you can't get any better than that, because if you change it any way, you're going to lose out.
Is that revenue maximising?
Yeah, not profit and revenue. Profit's a different thing. Profit maximisation, I can show you mathematically that it's MC equals MR if you want. I think...
We haven't even done anything in there yet.
Yeah, well, the year 12 didn't understand the economics, and you probably won't. Well, you would understand maths, but you would understand maths. I can do it for you if you want. It's like 2 lines, it's fine.
But do it like that.
I recommend the Year 11s don't take that for their supply and demand diagrams. If they had to do the 4 cases and they look at that, don't change price at all.
Yeah, and also, Mr. Speller said to me as well, I said to him that I was going to label the axes P and Q most of the time. He's like, oh no, must label the price because the market gets frustrated. So if I do P and Q, just don't do it in your exam. Don't say I did it, so it's right or anything. What I've written again is price elasticity of supply. That's going to be exactly the same. It's going to be P over Q. P over Q dQ by dP. I think so. I haven't actually looked at it, but it's basically the same. You can derive it if you're really interested. It's going to be positive though, because the law of supply says that price elasticity of supply is always going to be positive. And the final point I've written is the interesting question of cross elasticity of demand, which is how the quantity of another. A different. Is my watch right? What's the time?
10:02.
Yeah, it stopped working. It says it's 1:30. It says it's been 1:30 for about 20 minutes. Yeah, trying to stop for me. I've only got 2 more things to do after this, so we should. I might run over by about 10 to 15 minutes, but yeah. It's what I was talking about. Cross elasticity. That's how the quantity demanded of another good changes for the price of the good, a different good. So you've got, I think it's something like QDA over. Percentage change QDA over price of PB or something like that. And the problem you get there is that you're not going to have an equation which is that QD of A is a function of price of B, because that you can't find that, because there is no function which is going to link them, and therefore the problem you get is there's going to be no function, and you have to introduce something which even I haven't looked at. It's undergrad stuff, which is where you get it's the partial derivative. I don't want to confuse you, but that's just what you're doing when you're dealing with. And it's not that hard. It's not because you've got squiggly D's it makes it really hard. Basically, you just keep everything else constant. You can look it up in one of those books if you want. It'll explain it quite well. It's not hard, but that's just what you have to do when you're looking at cross elasticity. I just wanted to say that I've done most of the price elasticity demand, but price elasticity supply and cross is basically the same. My final one is I'm going to quickly talk through is consumer and producer surplus. And the GCSE mathematician in here will be fine with the first bit, and I think a 5-year-old could be fine with the first bit. But then I'm going to make it a bit harder.
But what about
Mr. Davis is daughter to do integration in all kinds of calculus and in the bath when she has the letters on.
Yeah.
He doesn't play with ducks in the bath, plays with numbers. So again, oh that's not bad.
I paid all myself.
P and Q's were nice. Again, going to look at straight line. Consumer surplus. in words, as are written on the board, is defined as the difference between what someone is willing to pay for something. So you could be willing to pay 50p for a Mars bar, and the price you actually pay. And if I'm willing to pay 50p and I get one for 25p, like, you know, there's that shop on the high street. Actually, I shouldn't probably say about that. I'll talk about it when I'm drawing on. There's a shop on the high street which is selling Mars bars for 11p, and I've said I've been willing to buy one for 50p. The reason why they were selling them for 11p is they were all going out of date. So they only had one day's date on them, so they had to lower their price to get them all to be sold. And I was willing to pay 50p, and I bought one for 11, so I got 39p consumer surplus, so I was happy. Even though I probably was thinking about that, which you might find is quite sad.
Work that every week.
Yeah, so the thing is that the price that's put on the market at the equilibrium is P star. So if we consider this point on the demand curve, which is where the consumer is willing, in the market, they're willing to pay this much for this quantity. They are willing to pay this much. Say this is my Mars program. I'm willing to pay 50p. But the equilibrium price was 11. And so 50 minus 11, this was all my consumer surplus. I should have drawn that as a straight line rather than a massive line, because it's the way I'm going to explain it. So just for this point, this line represents my consumer surplus, because this is the price that's enforced on all people on the market, even if at these points they are willing to pay more. The way the market works, they only pay this price for all of them. So this guy gets a stack of consumer surplus, and this is the point where there's no consumer surplus, because the price he's willing to pay is the price he pays, so he doesn't get any surplus. And now if we look at all of these individual points, and we consider the consumer surplus at every single one, we'd be drawing all these lines, and we find that it was this area. In consumer surplus, when you've seen the diagrams you draw at GCSE and AS level, you write that triangle, that area, as consumer surplus. So it turns out to be an area. And if I gave you the, I'm going to make up some example, I don't know what the functions are, but if I said that this point was, let's say 5, this point is 10, this point is 4, you can work out easily that this area is the area of the triangle. And this triangle has base of 4 and it has height of 5, so it's going to be 4 times a half is 2, times 5 is 10. You work that mathematically, the consumer surplus is 10. But that doesn't help us, because I've just been thinking about this while I'm talking. I'm trying to think how I can justify that it's a number, how consumer surplus represents a number, but it is a quantity really, as I would explain. It represents the difference between the prices in what they're willing to pay, so it is a number, that's fine. Now, the problem we have, I can't keep throwing to watch, I can't believe my watch is broke in the middle of this lecture many times. The problem we have is when we have this, and we have this. And now we can say, we want to find this area. I'll talk about this area later on. But even if we want to find this area, this isn't a triangle. That's producer surplus, by the way, that's the one that's underneath, that's consumer. This isn't a triangle, so we're going to have to do something fancy.
Ding dong, integrating.
That's one step ahead as always. And the thing is, let's look at producer surplus. Oh yeah, what I'm going to say is, the problem, we can't use this method, but I'm going to explain the method that works for every case using this method, because it's the simplest. And actually I could have done it in that method if I wanted to, but I'm just going to make it simpler. P and Q, I need to start speeding up because I haven't got that much time. I'm actually going to connect this up here, and I'm going to connect this up here. This area, those of you who know about integration, you integrate the y-axis with respect to the x-axis, you're going to get quite lost. Don't worry, you will have never seen this sign before, Matt will seen this sign before, because he was helping me with my integration on the bus.
What's that sign?
But if we, yeah, I'm going to say this point's Q star, and this point's P star. If we integrate this function in between here and here, what we're going to get is we're going to get this area, because it finds integration finds the area under the curve, this area. So it's going to be the integral of P dq between 0 and Q star, because they're our bounds, because we're integrating between these two regions. And the problem is that we can't just say it's this. We can't just say it's this, because if we say that consumer surplus is that, we get this area. This area. We don't want this area. What we need to do is we need to minus off this box, this square here. And this square, if we do this and we minus off the box, This is a nice equation. I've never seen an equation like that before. We get the triangle, which is the triangle that we want. So the